Hi guys, welcome to PyData Meetup for April. So today we have Jodhan Medina, right, who's currently a data science consultant at DVI Solutions Limited, and he's here to talk to us about beautiful data and why data scientists need to be good at data visualization. So before we start, we just remind everybody about the PyData Code of Conduct. So please be kind to others, do not insult or put down others, behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for non-focus. All communication should be appropriate for professional audiences, including people of many different backgrounds. Sexual language and imagery is not appropriate. Right, so PyData is dedicated to providing a harassment-free environment for everyone, regardless of gender, sexual orientation, gender identity, and expression, disability, physical experience, body size, race, or religion. We do not tolerate harassment of community members in any form. All right, so thank you for helping us make this a welcoming and friendly community for all. All right, so now, Jodhan, when you're ready, you can take it away.
Thanks, Chris. Good evening, everyone. My name is Jodhan, like Chris said, and I'm very happy to be talking to you all this evening. So a little bit about me before we start. I've been a data science consultant for the past 2 to 3 years. Let's just call it a couple of years now. And I absolutely love data. I think it's interesting, and I think we really and truly can't get enough of it in this day and age. So I know that's a bit nerdy to open up with, but just humor me for a bit. So welcome to my talk, Beautiful Data, and why data scientists need to be good at data viz. So we'll start off with a little tagline, a little saying. I'm not sure how many of you all have heard this before, but I surely have in my years at school and in my career, that data is the new oil. And where this is coming from is from the idea that back in the 19th century, oil was the discovery that propelled human achievement and human advancement so far forward into this new era, this modern era that we have right now. So because of oil, we had things like mass production of goods, we had more efficient transportation, we got to make buildings that are so tall that we can't even comprehend how tall these are. And we came about with a lot of great technology because of that. So currently, right now, the world is becoming more and more data-driven. So data is to us what oil was to our forefathers. Like I just said, human achievement left far forward by leaps and bounds with the advent of oil and the Industrial Revolution. And now we're poised to accelerate ourselves even further as the world becomes more data-driven. And you might ask, how will that come about? I'm sure a lot of you all know that already, but I'll still answer it. It's because, like I was saying, data is a gift that keeps on giving. So the newfound importance that we have put on our data has given us the ability to make clear and actionable decisions for the better, has given us a direction where we lacked before, and all in all, it's just plain interesting. Like sometimes I find myself lost in statistics and whatnot. When I was in research for this talk today, I can't tell you how many hours just researching GDPs of countries around the world and military spending and those types of things, just because facts and figures, they're kind of interesting when you look at it. And you could shape the stories that they want to tell a lot of different ways, but it's just all in all pretty interesting. And that's just one end of the spectrum. On the other end, there's a lot of numbers and figures being thrown at us, and that could cause a lot of like sensory overload, a lot of data overload, and we don't want that. So we want data professionals like a lot of the people here, like myself, like Prof. Torian and Chris, who know what they're talking about and who has know how to understand the stories and understand exactly what data is trying to tell us, so that we could enlighten the public and just reduce that sensory overload just a little. Right. So I've been saying stories a lot, and that's because, in my opinion, data is always trying to talk. Data is always trying to tell us something. And if you sit down and think about it, it really is the case. There's no scenario that I can think of. Somebody probably could come up with a really far out counter example for me, but at present, I can't think of anything that would generally come as a bad from understanding data better. So data is always trying to tell us a story, and it tells us a story primarily through our sense of sight, right? So this is a lovely diagram that I found doing research for this, and our sense of sight, it takes in information the fastest. It understands about over a gig of data every second. So it has around the same throughput as a regular computer network. Next is our sense of touch. It has the same power as a USB key. Next is our sense of hearing and smell. Next it has a sense of next is our sense of hearing and smell. It has the same power as a hard disk. And last is our sense of taste, which has the same throughput as a regular pocket calculator. Probably even less than that if you think about it. Now, if you really just sit down and think, this makes a lot of sense, because if all of us were stranded in the forest and there was a fire, the first thing that will alert us to fire is if we see it, right? Next would come if we feel a rise in temperature in our surroundings. Granted that we don't see a large flame just engulfing the whole forest, but like I said, the next thing that will come is a rise in temperature, and this is a lot slower than our ability to see the fire and react to it. Hearing is even worse, because if you've ever really listened to fire burning, it just sounds like something stepping on leaves and twigs, especially when in the forest. So that could be construed any different way. And I'm not sure if you want to taste the fire, you could go ahead, and if you survive, just let me know how that goes. Right. So I want to draw your attention to this little blip in the corner as well, right in between our sense of taste, and that is actually the amount of data that we can accurately and effectively ingest every second. And if you look at the number, it's, well, the arrow is blocking it, but right now it's 16 bits of data compared to our sense of sight, which could take in over a gig of data. That's not even 0.1% of what our sense of sight is ingesting in a second. So going along these lines, it's clear that our sense of sight is key to understanding the world around us. And I want to bring about just a short diagram to illustrate this. So this is a pie chart. I made it. I did it in Power BI. I like Power BI. I'm a Power BI kind of person. And it's a regular pie chart. Now, we're not going to talk about this right now. And I'm going to ask you a question, but you don't have to answer me. Just think about it to yourself. I want you to think of which section of the pie chart is the largest. It might be one of them. It might be two. It might be 4, 5. It definitely can't be none, but I just want you to sit down and think of exactly what is the largest section of this pie chart, because as you will see later on, if the visualizations that are portraying the stories that the data is telling us are confusing, then we ourselves are going to be confused. And if we can't understand what the data is telling us, then there's no way that we can move forward. So moving on. I know I already brought up the saying that data is the new oil, and maybe not everyone has heard that before, but I'm certain all of you all have heard this statement before, at least a couple dozen times in your life, that a picture is worth 1,000 words. So anyone who I interact with, I tend to say this to myself a lot, like, what does the data say? Like I said, data tells a story, and we have to be able to listen and understand what that story is to be able to move forward, make decisions, and ultimately just make some progress. So never has clarity ever come so easy to us humans. Our data is constantly speaking to us, giving us more and more information, but it's not always easy to figure out what it might be saying. So enter data visualization or data viz. This is our one-way ticket to better understanding what story our data is telling us. And this is an excellent point because, like I was demonstrating before, we're visual people. And if we can't understand something with our sense of sight, it's going to be very difficult for us to understand anything going forward in this whole data-driven space. So I prepared a couple of visualizations just to show you and emphasize this point that a picture is definitely worth 1,000 words. So this is a regular line chart shaded underneath, and it's representing something. So you can think to yourself, what might this be? And from the outset, you can already tell that it's telling a sort of story. There's a large peak in the middle of March. There's a large peak after Thanksgiving, close to Christmas. And then it just falls off and goes into the lowest dip it has on the graph on Christmas Day. There's a surprisingly large peak on April 1st as well. So so this is telling a story, and from the outset, you're seeing this. So what it's actually telling us is peak breakup times according to Facebook status updates. So what happened here was that two scientists from England, they ended up scraping Facebook in 2019 for status updates that said we broke up or broke up because of something. And this is what they found. So this is the story that they found. So there's not really any breakups on Valentine's Day, well, relatively speaking. People tend to break up a lot during spring break. I'm guessing spring cleaning as well. Of course, we're going to have a couple of breakups on April Fools because why not? A few on Mondays. Summers tend to be a little mellow compared to the rest of the year. And then right after Thanksgiving, there's one of the largest peaks on the graph, which is probably people sitting down thinking, I don't want to buy a gift for this person, so what's the point in staying with them? Of course, no one's really that wicked enough to break up with someone on Christmas Day, right? So next is this graph, and it's one of my favorite graphs that I've ever seen. It's called Mountains Out of Molehills. So what it does, it measures the intensity of media coverage of certain issues and certain topics throughout the years from, I think, 2000 to 2015. And of course, the larger the peak, the greater the intensity of the media coverage. So there are a couple of stories, especially because this is several different graphs in one. So I'll guide you through these. So the first four peaks, the four largest peaks on the graph, are in relation to pandemics and different outbreaks. Of course, if we had a graph going all the way up to 2022, we'll see another peak regarding COVID-19. But the largest peak we see is Ebola, followed by the swine flu in 2009 to 2010. Then we have the bird flu, which was, I think, 2005 to 2006. And then we had SARS. After that, there are other peaks, the dark red ones, and these are peaks regarding video games and violent video games in particular. You'll notice that it comes out late in the year, so around November, December time, when parents, grandparents, brothers and sisters are trying to think of gifts to buy for kids. And of course, what do most kids want these days? Well, boys in particular, violent video games like Call of Duty. I'm not sure who still plays Halo, but that's still a thing, right? And yeah, so there's always going to be media coverage, especially because people want to know if there's a correlation between violent video games and school shootings, etc., such as the unfortunate state of the US at the moment. Next, we have these very small peaks, these peaks in blue. Those are media coverage regarding killer wasps. Now I'm in Trinidad, so I don't really keep up with any news on killer wasps, but if you all are curious about that, I'm sure afterwards Prof and Torian know a lot because they're over there. And then the funniest peaks that I'm seeing here are for the correlation between vaccines and autism. Now, what I want you to notice is that whenever there's kind of a lull state between peaks of pandemics of different diseases, so like in between swine flu and bird flu, there's a really large peak trying to cover vaccines and autism, because such is the sad state of the world. A lot of people think that vaccines and autism are correlated to one another. Not even correlated. The vaccines cause autism, and yeah, and of course, unfortunately, there's that lull state in late 2001, because the world was so shell-shocked after 9/11. Right. So we talked a lot about stories and that data tells a story. Data is always talking to us. Now, we as data professionals need to be responsible and frame these stories very clearly, so that people who are asking very important questions, people like employers, people who are trying to build businesses and whatnot, who are consulting with us, they need to figure out exactly how to move forward or how to structure their businesses or carry themselves in such a way. So it's important to frame your story correctly, accurately, and to answer the right questions, per se. So I'm going to talk hypothetically speaking. So let's say we had let's say instead of we having these regular talks, PyData was a talk show, and there's an episode every week, every 2 episodes every week, something along those lines. And you know, people who are running it, like Torian, Jade, and Chris, they're trying to think of, okay, how do we get more viewers? I think we have a lot of viewers right now, but we want to reach out more. We want to get more people involved. We want people to know about us. So how do we get more viewers? So they hire 3 analysts, and the first one comes back sporting this diagram. Now, he's like, okay, I analyzed all your data over the past year. I couldn't figure out anything else, but noticing that you have a roughly 55 to 45 split in favor of males in your audience. Now, that doesn't tell anybody anything, right? That doesn't answer any of the questions that we had. It doesn't tell us what we can do to move forward and get more audience members. So the second data scientist notices this and is like, hey, okay, I can build on top of this. So he's like, all right, I'm going to split the viewers by the gender of the speaker. Clever thinking, right? So he notices that when there's a male speaker, there's roughly a 50-50 split between male and female viewers. So that doesn't tell us anything. But when there's a female speaker, oh, now look at the numbers. There's what, like a 65-35 split between male and female viewers. So this tells us a bit more of what we're trying to get at, right? So maybe in order to get more male viewers, we want to invite more female speakers to talk. But if we look at the actual numbers, the female viewers actually drop a lot when the female speakers come around. So what this isn't really telling us anything about our next actionable step, because what if female speakers actually are decreasing the number of female viewers that we have in the audience? Maybe girls are just not that interested in seeing other girls talk about data science. Maybe they're coming to see the nerds like me talk about data and why they think it's so interesting, right? So second guy did a bit better than the first, but it's not really cutting it. Now the third guy, he comes with a something better, a time series, right? So he's saying, all right, I plotted your viewership over the full year that you all have been doing this so far. I have split the viewers by their gender so that we could see clearly what's happening. And he's showing us that regardless of who is speaking, the male viewers are increasing, even when there are peaks with, even when there are troughs in the female viewership because of female speakers, there's no increase or decrease in their male viewers. So what's that saying is that males are increasing over time. But now look at females. There's a peak every time, and I didn't show this on the graph, but there's a peak every time there is a male speaker. Well, that's interesting. So if males are not affected by the speaker choice, but females are, then maybe the right step moving forward is to hire more male speakers so that both the female and the male population of viewers would increase. Now, that's a clear insight. That's a clear actionable step, and they'll probably pat the guy in the back and, I don't know, give him $1 million or something like that. I'm not sure what the economics are in that world. So I was a good hypothetical situation. Now, moving on from that, what goes without saying is that the story that you're portraying needs to be carefully portrayed, as in data can't be skewed towards a story that you want to show a viewer. It needs to be honest, it needs to be transparent, and you need to be honest about what story that you're telling, because there's nothing worse in this field for a data professional to be labeled as dishonest, because you will lose the trust of literally everyone, and yeah, that's just not the way to go. So here's an interesting graphic, right? So this is a graphic demonstrating the top 10 military spenders of 2020, and I mean, unsurprising, the United States is the largest, and the United States could easily fit the other nine contenders in the top 10 inside its military spending budget, just because it's that large. So this might go and resonate with people who have this view of the United States, that it's this warmongering country, that it has its bombs, its nuclear weapons, and it's ready to go to war at any point in time. But that's not the whole picture, because when you think about it, the United States also earns the most money out of any country in the world. It's the largest commercial hub in the world at present. So much so that its GDP in 2022, I believe it was 21 trillion. GDP in 2021, sorry, it was about 21 trillion. And it's so large that it could hold the GDP of Japan, Germany, and North and South Korea in it and still have enough left over for dessert. So if you take from that and you look at the proportion of the GDP that's actually going towards military spending, you get a different picture. Unfortunately, I didn't have a super cool graphic to show, but these are the top military spenders as a percentage of GDP in the same year, 2020. And this is a different picture for sure, because there's no mention of the United States anywhere here, no mention of China or North or South Korea, which some of us might think are warmongering nations. The highest is countries like Oman and Saudi Arabia and Algeria and Kuwait, Israel, who spend roughly 5 to 12% of their GDP towards the military budget. The United States barely even makes the top 20 because it spends around 3% of its total expended of its GDP on its military budget. So we need to be careful of the source that we portray. And another case of this would be like China. China right now has the largest active military, but when people say that, they fail to realize that China also has the largest population in the world. When you look at countries in terms of their population, in terms of the total population, and find out how many active military members they have per, say, 1,000 capita, you will find that China doesn't even break the top 10. It's actually South Korea or North Korea, one of the Koreas that's actually first, right? So yeah, so just we need to be careful of the source that we portray, because a lot of people are relying on us to portray accurately and portray effectively. So as effective as you might be, the story needs to be honest, and you need to be transparent about what you're doing. What is a good design and what is a bad design? Well, that's $1 million question, right? So there are a lot of bad designs. A little fun fact about me: I love graphic design. I practice as a graphic designer. I wouldn't call myself a professional, but I could throw down if the need comes, but there's a lot of bad designs. And why is that? Because people don't follow a bunch of basic principles that I learned while learning how to design graphics and whatnot. And therefore, it's pretty straightforward. And the first being to make it people friendly. And what do I mean by that? Well, we're people. Humans are the only people that at present could understand the data that we are producing. So we need to put it in a format that people could easily and not too difficultly work out what the data is trying to say. So I'm going to bring back the example of the pie chart from earlier. Now, this is a terrible visual because it doesn't say anything. You can't figure out which slice is largest. You can't figure out, well, you could probably figure out which is the smallest. Hint, it's orange. And there's no way of discerning exactly what it's trying to say. Do the colors mean anything? So this brings me to the point that two scientists made a long time ago. The names were Cleveland and McGill. They conducted experiments on human beings and trying in order to determine what medium of representing data was most effective at communicating a point so that we'd understand it very easily. And they found that color and color saturation, shading, etc., was the worst metric. It's not a bad one. In some cases, we know that red is bad, blue is good sometimes, I suppose, and white going to black would be bad, white would be good, those types of things, but it's not always the best. So what they found was that position and length, when organized in a diagram, were the easiest for us to understand what's going on. And now the problem that the pie chart that I was showing you has is because it's trying to combine angle and area, which are the fifth and sixth best effective explainers of data. Now, if we were to say, take this confusing pie chart and organize everything in terms of a bar chart, picture becomes very clear now, doesn't it? It was so unclear before that I thought green was the largest, actually. I can't remember coding it like this, but yeah. So the next point is to make it simple. Cool graphics aren't always good graphics, and a lot of graphic design comes from being able to make cool, stunning visuals. So I do a little bit of like brand design and whatnot, and a lot of the allure of that comes from being able to, you know, change something basic and something simple into something that just makes people intrigued by what this thing is or what this place is or something like that. So yeah, so that's just the field of graphic and brand design. But in terms of data viz, cool graphics aren't always good graphics, because I'm going to show you something that I thought was pretty cool. I came across it last year and I absolutely loved it. It was this diagram. Now, I would ask you to try and figure out exactly what this is and what it's trying to say, but I don't think any of you will be able to figure it out just because it's so confusing. There's so many colors, there's so much area, there's so much difference with the positions. Do we know if up and right are good? Do we know if left and down are bad? Do we know, does blue mean good? Does red mean bad? Vice versa. What does yellow and orange mean? Those types of things. It's very difficult to figure out exactly what's going on. So if I put all the labels on this diagram, you're going to realize that, right, yes, it's the note frequency for the song Claire de Lune organized by the pitch, by color, organized in the position of accidentals by the position above and below the middle line, and organized in the position of notes along the piano by the octave, left and right. Now, even if I told you this, it's still not good as a design. It's cool, it's pretty damn cool, and I would put a poster of this in my room if I could print something this big, but it's not effective at explaining the point, because if I were to sit down and ask you all what note is played the most in the song, or what note is played the least, you'll most definitely won't be able to tell me. I for sure can't tell myself. If I were to ask you all how many flats there are or how many sharps there are in this song, I highly doubt you all will be able to tell me, just because this is so confusing. And I think the most confusing graphic that I've seen in all my life is this, the BBC's avocado toast index. And my biggest question is why? Because it's trying to depict, I'm going to explain it because it needs to be explained. It's trying to depict the average cost of a deposit on a home in two different cities, Johannesburg and Mexico City. And it uses avocado toast by the hundreds as a unit of measurement. Now, what's confusing about this is, first of all, why avocado toast? Why 100 avocado toast? First. Second, why avocado toast on the whole? Third, Mexico City's price of an avocado toast is far greater than the price of an avocado toast in Johannesburg. So even though we see that Johannesburg needs more avocado toast to put a deposit down on a house, the house costs cheaper. So a graph like this is so confusing and so complicated that it just takes away from the general idea and the general takeaway that you want to have with your audience. So it's just terrible. And yes, like I said, there are a lot of bad designs, and even big namesakes like BBC do make these mistakes from time to time, just because they're trying to be a little out of the box. So the next point that I want to make is to make it quick. Data needs to be ingested in the first second of you watching it. You need to be able to figure out exactly what's being said and how does that, what's happening, is there any change, how does it affect me, those types of things. And yeah, and if you can't do that, then it's more than likely going to be a very terrible visual. So I'm going to bring the avocado toast deposit graphic down back again, because if you look at this, you need to look at this carefully for a few, say, 30 seconds to a minute to be able to understand exactly what's going on. And even when you do understand it, it doesn't exactly say anything. It would have been a lot easier just to represent this by 2 bars showing that Mexico City costs significantly more money to put a deposit down on a house than Johannesburg, and it'd be done. It'd be easy, quick, and I think any of you would have been able to get that within the first half a second of watching it. So on to an example of an actually good graphic is this. Now this is good. Even if I took the text away, took away the fewer children dying, took away the percentage dying before the age of 5 worldwide, and just left you with the years beneath and the 3 percentages on the graph, you will be able to tell exactly what's going on. You see an exponential decrease in something, you may not know what it is, but you would be able to see within a second that there's an exponential decrease in something from the year 1820 to the year 2020. Something's decreasing from 43% all the way to 3.7%, and that is staggering data. You're going to want to know more about it and what's happening, and then you're going to read the title and whatnot and be able to understand that, oh, in 1820 the child mortality rate before the age of 5 was close to 1 in 2 children, and now it's barely even 1 in 20. So, and lastly, last point I want to make is to be transparent. Now, transparency, we talked about this before. You need to be able to communicate what you want honestly so that you'll be trustworthy and people would be able to trust the data that you're giving them. A lot of times in my line of work, I would come across findings that don't really agree with what I expect them to be. Say you work for an insurance company and you predict that male claims are going to be higher than female claims. But when you look at the data, you see that females are higher than males. Now, that might be alarming. You might want to change that, because a lot of the people that you're going to present this data to is going to wonder what's happening here. Did you even do your job properly and whatnot? But no, you need to present the data as it is, because that's going to open up doors for you in terms of you don't know if the data that you were given is complete. In my experience, I've had those things happen to me before, and it just opened up a dialogue with me and the people that I'm preparing the data for, and they would realize things like, oh, they didn't give me and my team all the data, or they didn't something they thought they had there was apparently wrong, and the data is actually correct. So you need to be transparent. Now, this man's name here is Kurt Wells, or Kent Wells, I believe. He was one of the directors at BP when there was the whole oil spill back in 2010. And this was a photo taken at one of the talks he was having, just to show. And the tagline for this talk was that we're ramping up. So he used this graph to show that the oil that they were collecting on a daily basis was actually increasing. So say the first day they collected 2, he was trying to show that, okay, the next day we collected 4, then 6 and 8. So we're constantly ramping up. Now, he didn't explicitly lie in this, but the graph that he's showing is not actually the daily average oil collected. The graph, as you could see, as the title, is the cumulative oil collected. Now, what was happening here is that he and his team were using our innate sense of sight against us, so that we would, after seeing bars on the up and up, we'd automatically assume that, okay, this has to be a day-to-day thing, so they're ramping up, and we'll take everything that he's saying at face value and not even question it. But if you look closely, it's a cumulative graph, so it's going to be ramping up actually. And I could show you the more accurate values for this. So yeah, so we could see on the first day they collected 200 barrels of oil. Then by the second day it was around 1.5, 1.6, I can't see too well. Then the third day they collected 3.8, and so on and so on. So it's ramping up, but that's only because they're collecting oil cumulatively, and they're looking at it as what they've collected in total. Now, if we just subtract the values from day to day, we'll be able to see the daily oil collected and not really ramping up. Maybe in the first 4 days, yes, but afterwards it sort of tapers off and falls off to even below the average before they fall off. So yeah, so this is an example of being transparent. We need to be able to be trustworthy, and I'm not sure if people at the time figured this out, but this was something that was shown to me recently. But if people at the time figure this out, I'm definitely certain that BP would be a lot less trustworthy in their eyes. So let's bring it all together. So we talked about the 4 principles. You need to be able to make it simple, make it quick, make it people friendly, and be transparent. So how do we put all this together and make some magical with it? Well, I'll tell you, and I'm going to take you back to 1854. Now, for those of you who don't know, back in the 1800s, cholera was on the up and up. It was all the rage in England, in different cities and whatnot. There would be outbreaks of cholera from year to year, and this was just becoming a regular occurrence. Now, back in those days, people thought cholera was airborne because we didn't know what germs were back then. So people thought cholera was transmitted airborne and by some substance called miasma, or bad air, so that when we inhale it, we just get cholera. And a lot of people thought that, okay, this has to be God's truth. I believe the church, the government, most physicians of the time believed that as well. But there was one dissenter, and his name was John Snow. Not that John Snow, talking about the real John Snow. So this is Dr. John Snow. He was a physician and he came up with a theory back in 1854 that cholera wasn't airborne, but it was waterborne. So it was actually in the water that we were drinking. And he went to his colleagues, his peers, the church, the government, etc. And he presented his theory. He wrote a whole scientific paper about it before. And they looked at him, they laughed, and they said, I don't think you know anything, John Snow. You know nothing. And so he did what any self-respecting scientist would do, and he went to gather data. And he did this by going house to house in a city called Soho in England, where there was a cholera outbreak along a street known as Broad Street. So he went to house in all the neighboring streets and all the neighborhoods that were circling around Broad Street, and he took down how many deaths there were, and he organized this in a map. So a very nice, well-drawn, people-friendly map. If you zoom in, we can see that he organized the deaths by bars along the streets just to show exactly where the deaths were occurring. Now, what was interesting about his findings is that back then, people used to get their water from pumps, and the pumps were located at on the crossroads of many streets. So there was the Broad Street pump, coincidentally, and he found that if you look closely, near the pump in the center on Broad Street, there was the highest concentration of deaths due to cholera. So this not only confirmed his theory, but it made him go back to all the people that told him, that laughed in his face, and they were like, you know what? You know something, John Snow. So John Snow published this work, and it gave rise to a lot of the findings later on that will contribute to the study of germs and the study of disease and whatnot. But the interesting thing was that these pumps were so close to these houses on the streets, and back then houses were so close, they were built upon cesspits, so that's where they would dump all the waste and whatnot. And they found that the water coming from the pump was actually contaminated from the cesspits underneath the houses along Broad Street. So that was giving rise to the whole cholera outbreak. So he went and he talked to the government, talked to his friends and whatnot, and they made their changes. They changed how they changed the cesspits and whatnot, and within the day the deaths went down. And an interesting thing to note too was that there were other pumps around the city. Along Bridal Street, for example, there was a pump along there, but there weren't many cholera deaths, and that's because the water wasn't contaminated. So what I'm trying to put together right now is that to be effective and efficient at data visualization, you don't need a lot of fancy graphics. Actually, John Snow did all this hand-drawn. The map that he did was hand-drawn, actually. So you don't need fancy technology, you don't need fancy visuals, you definitely don't need cool visuals or graphics to be effective at conveying the data. All you need to do is make graphics that are people-friendly, graphics that are simple, that are quick, and all you need to do is be transparent. So I want to just take you all through a couple libraries in Python that I like to use for my data visualization right now. Maybe that will inspire you all to use them on your own, maybe explore them and whatnot, but I think that they're actually pretty fantastic. So without further ado, let me show you what those are. Right. So this is my Jupyter notebook, and the crucial thing about a lot of these packages is that some of them don't work with Google Colab or Jupyter Lab, which I tend to use a lot. So I had to use Jupyter Notebook just to make this tutorial. So the first package, and I'm only going to go through three, is Altair. I used to use this a lot last year, just because I found it and it was pretty cool. And it gave rise to a little bit of interactivity that packages like Matplotlib and Seaborn would not otherwise give you, but it's also a bit clunky to work with. And I'll show you. So we'll start by importing our packages. And if we want to make, say, a simple line graph, the code, it's not that far. It's a bit different from Matplotlib and Seaborn, so that's something to get used to. The crucial thing about this is that it's built on a software called Vega. Don't ask me anything about Vega. I'm no Vega expert and whatnot, and I only know that just because I used to see it come up in the discussion. So if you have experience with Vega, this is going to be a lot easier for you just because the code will be similar. So let's say we want to make a stock, a graph of stocks and whatnot. Now, the code is very straightforward and it runs relatively quickly. So now this is good if you want just something to easily save as a picture and whatnot. You don't need to do the whole save fig that you will have to with Matplotlib, but it's static. It's not really interactive or anything like that. So what we can do is take this code, and what Vega likes to do is if we type .interactive at the end, it makes it a little more interactive, so we could just move it around and whatnot, but still not the best, because if I want to see, like, say, the price of a stock at this day, the code is very much convoluted. It's pretty much as convoluted as it can be in Matplotlib and all those other packages. So yeah, let's stay away from that. So I'm not going to show that here because there's another package that I will show you later on that does this in one line of code, essentially. So yeah, so we could do everything that we want to do in Matplotlib in Altair. It's very simple, very straightforward, and yeah, there's even this just a simple line graph that I did on the price of a stock. I believe this is Tesla over the years, and yeah, so you can see it's simple. It's not for everyone. If you like the styles that it has, because when I started coding, I loved Seaborn for some reason. I had a friend who he would always argue with me that, oh no, just use Matplotlib, and I'll tell him no, because Seaborn just looks nicer. So I understand that kind of need for aesthetics and whatnot. So if you find that this just looks nicer to you, go for it, try it out by all means. Now, there's also this next graph, and I'll reproduce it much later on, but it's a graph on of the unemployment rate in different counties in the United States. And in Altair, could produce something really nice, really good looking. We can get a rough idea of what's happening, but it doesn't give any labels. It doesn't tell us where the most unemployment is. I'm not from the United States, so I definitely don't know which state this county belongs to, even though it's definitely the highest unemployment rate. So yeah. So next is bokeh. And out of the three that I'll show you, bokeh is my least favorite, just because all the convoluted code that I said that Altair requires you to write to make it interactive, bokeh does that, but like 10 times worse. So yeah, also it requires a lot of different packages and whatnot to run, especially because on, say, Jupyter Notebook and Jupyter Lab, you can't run bokeh straight out of the box. You need to install different extensions for Jupyter Notebook just to be able to visualize your bokeh graphs. So I'll load some sample data, right? It's already loaded, and import my data set. So this right here is a graph of stock exchange. It's a bit interactive, and as you can see, it requires about 20 lines of code just to make it as interactive as I'll show you. So, right, so this is the Apple stock, and it has good functionality. We can move it across. We could see exactly when certain prices were. We could see the peaks, the troughs across the whole period. And we have the slider down here just to demonstrate. We can even shrink it a bit just so we can see it on a much shorter time frame, but yeah. So that's it for bokeh. I don't want to go into that any longer because I absolutely despise Bokeh. But the cream de la creme is Plotly, and I love Plotly. I use it in everything that I do with if I have to make visualizations for work, if I don't really want to do it in Power BI or Tableau, I'll just plug the code into Plotly because it does it very easily. So like I was demonstrating above here, we need about 20 lines of code just to be able to make a slightly interactive graph in Bokeh. And we'll need even more than that in Altair, but in Plotly, we can do that with 4 lines of code. Right, and we have the interactivity. We can see that, okay, on July 2nd, 2018, the value of Netflix was 1.94 units. And you can see on September 2nd, 2019, Apple was valued at 1.21 units. We can even add a little slider down beneath, I believe. Oh, no, I don't have that yet. Right, yeah. So we can also generate this graph. So this is essentially what was being shown up here by Bokeh. So Bokeh required, like I said, around 20 lines of code just to be able to make a slightly interactive graph. But now in Plotly, 4 lines is seeing it for yourself, and the graph is as interactive as we could want it to be. We could scroll around, we could see that on October 13th, 2016, Apple was valued at 117 units. Let's see, right, yeah, it's actually fantastic. I love using Plotly. So this next one too, we can actually add a little bit more functionality to this graph. So we always see in the stock exchange, we can see the value of a stock over a minute, over 6 minutes, over a year, or over all time. So this 10 lines of code actually does that. So it adds the filters on the graph. So we're seeing it at all time right now, but what if we wanted to see the stock value over a minute? Now we have it right here. What about over a year? Over 6 minutes, right? So that's the beauty of Plotly. It makes a lot of the interactivity that we might want a lot simpler, and it comes built in with this. So for those of you all who like to be able to just view your data and see exactly what's going on, I mean, in Power BI, they do it there too, in Tableau as well. But for those of you who want to be strict with using Python, go for it. And I believe it also is available for R users as well. So if you're not a Pythoneer or Pythonista, go for it in R as well. So then Plotly also has the ability to animate things very quickly. So we have this data on the GDP per capita versus the life expectancy of different countries. I'll visualize that right now, right? And by adding 2 arguments, animation frame and animation group, we are actually able to animate this throughout the years and see how the data moves itself. So that is pretty neat in my opinion. Then we can also do that bar graphs on the same data and just see what let's visualize the population of the different continents. And if we saw that, we see, okay, cool. There's a big boom in Asia, and it's going all the way up to about 3.75 billion people there. So we know that's where half the world's population resides right now. So Plotly is good for general interactivity. It's good for animating things, but we had this whole choropleth map above, this graph of the United States, right? That showed unemployment rates by county. Now, with Plotly, we can actually make this very interactive with around the same lines of code that Altair used to make a static image. So if we load all this right now, and it'll take a while, just a sec. Right. So if we load this, we actually get a very nice map that shows all the counties in the United States of America and their unemployment rates. So I could go, okay, let's see, where's this? Los Angeles. So look at this county, the unemployment rate is 5.2, which the last graph wasn't able to tell us. Of course, we have missing data here. I believe that's a lake, I'm not too sure. Could be a county as well, but yeah, so these are just some of the things you can do in Plotly. And the last thing I wanted to show you was that with this, I got some code to run to make a choropleth map of the world, and using COVID-19 data, we're able to show the spread of COVID-19 across the world. So let me visualize this for you all right now. And it'll take a little while just to load the data and to run through the for loops that were made. Okay, it's taking a bit longer than usual to run. There we go. So right, so we have a choropleth map and the data is up to date. I believe the last day is April 19th, or it should be close to today because this data is live. So I won't play this just because it has so many dates to run through. It started January 22nd in 2020, by the way, and that's about over close to 900 days we'll have to run through, but just a quick scan through, we could see that COVID moved from China and it's spreading across the world. Now we're seeing confirmed infected cases in the US, India, Brazil, Alaska, and now to the present day, where there's a lot of confirmed cases worldwide. We can even zoom in on this, and fun fact, Trinidad is here. And it shows accurately how many confirmed cases we have. So we have, I think in total, we had about 141,000 confirmed positive cases. So yeah, so showing that we're at 142. So maybe not in line with the data that we have here, but definitely accurate and up to date. We could find how many confirmed in Cuba, 1.09 million. We could go to Dominican Republic. We could go anywhere, the US, 80.63 million confirmed cases to this day. So yeah, so those are just a taste of the types of things you all can do in Plotly. It's a very great Python package for any of you all who are looking for just something new, something different, something that's not as standard as just using pandas or matplotlib to demonstrate and visualize the data. If you ever just want to bring that little interactive element or bring some animations that could help demonstrate your point a bit better, then I think Plotly is for you. And with that, that concludes my talk for tonight. I would like to thank you all for listening, and I'll open the floor to any questions you all may have right now.